variable bugs, which don't have to occur always, but sometimes they do, and if they do, things are going to be bad. Okay, further questions about this? So again, what's really important to me is that you get the nature of guard patterns, that when you write code, like, okay, first come the spaces, then the plus minus, then the 42, you write 3 guard patterns, and the first guard pattern gets rid of the first problem. The second guard pattern gets rid of the second problem. The third guard pattern gets rid of the third problem. And so you can reduce a complex input into a very simple form just by applying not only one but multiple of these guard patterns in order to get to the core. This is the basic principle that almost always happens whenever you write some kind of function. Also here, you have a guard pattern that reduces a complex case to a case that's easier to handle. And in the end, the last thing should be return and then some kind of value, which is the most simplified version of the entire problem. In this case, the value would be the value to return here. So you just keep reducing with these guard patterns until you really get to the last value, which is what you're going to return. Okay. Just out of curiosity, has anybody approached programming like this before? Or, okay, that's good. Who's not familiar with this style of thinking? Okay, so maybe like 30 or 50% who are not familiar with that, which is okay, because this is a way of thinking that is not common. So you might have some kind of problem-solving capabilities that you might use in your everyday life, but when you code, you often need a different mindset. You need to know what's given and what's needed, and then you need to insert from a pool or from a dictionary or whatnot of patterns whatever you need, and you need to place them together like some kind of Lego bricks in order to tackle the problem. Many people that start out usually just say, okay, let's just take the simple case and do this until it works. And then we wrap it in some kind of other pattern. And then we wrap it in some kind of other pattern. So you have something like, if it's a space, or if it's not a digit. So I'm seeing many people do this, maybe this, or maybe an and statement right after that, and so on. If you see something like this in your code with very long statements, you're already on the wrong path. You might be tempted to say, okay, it's not quite working, but if I insert something here, then it's working better. And if I insert something after that, and maybe put a while statement in here, this gets rid of the other bug that I had, but now another bug is occurring. Okay, so I'm going to put another if statement here just because it works. Now, as you can see, the code that you grow from this is not very structured. You don't have a 1, 2, 3 approach. You have a block of code that's growing in some random places out of your debugging session. It's not growing out of looking at your problem, breaking it down and following it step by step. It's growing out of, well, I have something, let's mutate it into something that works more as expected. But what you're going to end up with is a very long line in if statements, or multiple if statements, even words. And once you have that, even keeping track of the logic that's actually happening here, A and B, or not C, even this one is complicated to keep all the options or possibilities in your head. And once you see yourself writing this kind of code, try to take a step back, cross it out, and try to put it in, break it into smaller pieces and try to solve them one by one using this guard pattern analogy, because otherwise you're going to mess up with a pretty high chance. If you don't, then the person debugging this after you is going to mess up quite easily. So this is really important because most developers write something, but another developer is then going to take over their work and continue with it. And even though you might be the one understanding it, always make sure that the other person can understand it too, because nobody wants to look at a piece of code not knowing what it does because some genius or maybe anti-genius wrote it, and you need to look at it for 30 hours until you know what it does. This is not how we write good code. This makes you slow, this makes you frustrated, and writing code while being frustrated is exactly like writing code when hungry. It's not going to work. Okay, so in order to make other people, or make it easier for other people to understand your code, reduce it to simple patterns. Okay, this was the part about the guard patterns. The last thing is the main patterns, as I call them. And once we have that, we're going to do a short excursus on pointers, and I think then we're done. Does this sound okay? Or yeah. Okay. Now comes the most important part. If you have all the guard patterns in place, what's going to happen is you need to write the main part of your function. Guard patterns only protect you, but I haven't told you what to put inside of the main block. And there are a few common patterns that occur in most of the functions, especially in the libft. I'm going to walk you through them now, and after each and every one of them, I might do a quick vote which one of you have already seen a pattern like this before, just so that we can see how common it is. So I'm going to write them down, and you just raise your hand when you start noticing what I'm writing down, and maybe you can even explain or talk about what it does in your code. So just to make things a bit more interactively so that you can see that these patterns are actually pretty well established, or at least I hope so. Might be a few surprises in here. Okay. Right. So, let's get back to back. The first pattern that I'm going to write down is, of course, you need the int I. This is a case where the initialization doesn't always have to be the first thing, because you can nest these patterns, and if you nest them, you cannot put all of these I equals 0 at the top. So this is one of these cases where the initialization doesn't always have to be at the top, but we'll get to that. Okay, raise your hand once you notice what I'm writing down. Okay, already a few shy hands coming up. We might even generalize this and put some kind of n, which is an integer. Okay, who's familiar with that one? All right. Somebody willing to tell us how this pattern works in your code, what it does, where it appears maybe. It doesn't have to be a very in-depth explanation, but which function maybe are you using that in? I mean, all of you have written this at least once probably, so you all should have an idea where it's used. Yeah, this might be one application. Anything else? Okay, is anybody familiar with B0 yet? Who's not? Okay, B0, what it does is it takes a chunk of memory. I don't know if it's a void pointer or a char pointer, but it doesn't really matter. And it also takes an size t n, which is the length. And what it does is it gets this piece of memory, so the pointer goes here. It has a size of n bytes. And what it does is it fills in 0 at every location. So it starts at index 0, 1, 2, 3, 4, 5, 6, 7, 8, goes until n, which is in this case 9, 0 through 8. And for every one of these, it repeats this. So this is a repetition pattern. And for example, in B0, what this does is it just repeats putting a 0 into some kind of data block multiple times. So this 0 comes from here, and we're just repeating this n times. This is the first pattern, and you have seen this before, which is good. Now there's a different one, which is related. So this was the repetition pattern. I'm going to write its sibling now. I need a bit more space. Let's say you have a string. It might be a parameter or it might be a variable, we don't care. It's somehow initialized. So it's already initialized. Hands up if you notice what pattern this is. Okay, that's a bit less than before. Okay, but you might have seen this. This is actually what usually happens in the STR. What this does is it repeats something a fixed number of times. You already know how many times you want to repeat something. In this case, you don't know how many times, but you do it until you hit the end. This string might have length 0. This string might have length whatever. It could go on until maybe 1 billion or 2 billion. In the end, every string has the \0 character hidden in it. That actually comes after the string. So what this does is it doesn't repeat a fixed amount of times. So this is the fixed amount. No, it repeats until the end. And this is what I call the string iteration pattern. So this is the repetition, and this is the string iteration pattern. Yep.
So is it possible to just put S in there, or is there also something funky that could happen?
That's something funky, because while S, like this is what I was actually aiming towards when talking about the pointers part. There's a difference between S, like putting an if statement with this, an if statement with *s, and an if statement with *s unequals \0, and if *s unequals the number 0. Again, the number 0 is something we can already cross out, because comparing numbers and characters, a string again is a bunch of characters, is something you probably shouldn't